Okay, so I'm clearly out today. And so you're watching this video. We're going to work on these notes together. So this is the notes for 3.4, number 2. The substitute in class should have given you a paper copy of these today. And then the homework, let's see, that would have been, I guess, homework 3.4, number 1, which is due today. Just hang on to that, and we'll review that the next time you see me in class. Okay, so we're going to review a little bit of permutations. We already looked at this formula last class, but a permutation is a number of ways of ordering a set number of items. So, for example, we say a permutation of n. So I have n items, n things. And I'm going to choose R of them. So N and R are representing they're variables, representing values, whole numbers. So N is the total number of items. N is how many of those items I'm choosing. And here we're interested in the order, right? So in other words, let's say I'm putting books on a bookshelf, right? So I have a bookshelf and I'm putting books on it. I have 10 books to choose from. So I have this pile of 10 books, right? I have this big pile of books, and I have 10 of them, and I'm going to choose 7 of them. And I want to know how many ways can I choose 7 and then order them in a very particular way. So if I choose the 7 books, that is like one way of ordering them, but I could reorder them in lots of different ways, right? So this is going to all at once tell me how many different ways there are of choosing 7 items out of 10, and then how many ways can I order them, those 7 things. All right, and so it's called a permutation of N choose R. So our book uses this notation to denote this. And then what you do is you take the total number of items. So in this case, where I had 10 books, but I wanted to order 7 of them in my shelf, then it would be a 10 factorial over the difference of the two. So 10 minus 7 is 3 factorial, right? So, and then we want to simplify that. We also learned last class what factorials meant. So 10 factorial, remember, is 10 times 9 times 8, all the way down to 1. And then, of course, 3 factorial, that's easy. That's 3 times 2 times 1. Sometimes we'll just think of 3 factorial as 6 because that's what 3 times 2 times 1 is. 10 factorial is too big. We would end up using a calculator for that. So, if you don't have calculators, somebody go to the front of the room and open my cabinet where the calculators are and get those out for everybody to use. And then if whoever gets them out, if you would be responsible for making sure they're all there. 2 of the slots don't have calculators in them. There's 20 slots, there's 18, so there should be like 2 that are missing. Not really missing, they were never there. So whoever gets them out today for everybody to use, if you would put them away before you leave class, that would be great. All right, so let's use this formula then in doing some examples. So we have 5 choose 3. So I have sort of a bunch of lines here. You may or may not need that many, but kind of I'm thinking like, oh, well, you'll use that formula to write it out. So this will be 5 factorial, and so then we do 5 minus 3, and then in parentheses factorial. Now remember, you have to have parentheses here. This is not, so 5 minus 3 factorial is 2 factorial, right? But if I say 5 minus 3 factorial, then that's 5 minus 3 factorial. 3 factorial is 6, so this is actually -1, right? So you just got to be careful. We don't mean 5 minus 3 factorial. We mean 5 minus 3, that quantity, whatever it is, and we're going to take the factorial of it. So make sure you have parentheses around that denominator. Okay, so that means 5 factorial over 2 factorial. And again, you might not write it like this. You might just jump to this step. That's fine. And then we want to write it out. We want to say 5 times 4 times 3 times 2 times 1, and on the bottom 2 times 1. And now everything upstairs is getting multiplied, everything downstairs is multiplied. I can cancel. 1 cancels with the 1, 2 cancels with the 2. So right now on the bottom I have just 1, right? I mean, when you reduce a fraction, it's not a 0. So like if I have 10 over 5 and I cancel out the 10 with the 5, this is a 1 and this is a 2. So there's still a 1 down here. We don't really need to write it. So really it's 5 times 4 times 3. And 5 times 4 is 20 times 3. This looks like it should be 60. So there's 60 ways of choosing and ordering 3 things taken out of a total of 5 things. All right, next one. 6, a permutation of 6, choose 4. So go ahead and fill that one out. So I'm going to use all my slots. So 6 factorial, and then 6 minus 4 factorial. And then we have 6 factorial over 2 factorial. And again, we can sort of write that out. 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. So this is simply going to be the 2 cancels with the 2, and of course the 1s go away, leaving us with just 1 downstairs. Upstairs we have 6 times 5 times 4 times 3. So I think that's 360. Okay? But do that in your calculators, double check. All right, next one. 7 items, we're choosing 2 of them, so it's a permutation of 7, choose 2. All right, so we get 7 factorial over the 7 minus 2 factorial. And then we have 7 factorial over 5 factorial. So this top is 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, we have 5 times 4 times 3 times 2 times 1. And then you can see how the 5, 4, 3, 2, 1 cancels with the 5, 4, 3, 2, 1, right? So this is really just 7 times 6, which is 42. Okay? All right, and the last one is a permutation of 5, choose 5. So maybe I'll skip over this one step. I'm going to just go over here and say, that's 5 factorial over the difference, which is 5 minus 5, which is 0 factorial. Remember, 0 factorial, always equal to just 1. And so we have 5 times 4 times 3 times 2 times 1. And do you remember what 5 factorial is equal to? That is 120. So I think we said yesterday that there are certain things you should probably just commit to memory. 1 factorial, well, 0 factorial is 0. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. 4 factorial, 24. Sorry, those are not looking like exclamation points. They're looking like colons. 5 factorial is 120. 6 factorial, 720. So if you just know those and commit those to memory, sometimes it's a little helpful. So you don't have to like pick up your calculator and say 5 times 4 times 3 times 2 times 1. If you just know that 5 factorial is 120, it'll save you a little time sometimes. Okay, let's go on to the example 2. So Mr. Rogers decides that he's giving out first, second, and third place awards to the students who show the most effort this marking period. How many ways can he choose? So, I mean, obviously, he would look and see, but if he's just choosing them, right, sort of randomly, I guess, then how many ways could he choose first, second, and third place? So the order matters here, because if you get chosen for the first place award, that means you've shown the most effort. Second place, you get the second most effort, and so on. So the order is really important here. We're going to learn in a future lesson when the order doesn't matter, there's a different formula that we're going to use. But here, the order matters. All right, let's see. How many ways can he choose 3 students from a class of 8? Well, 8's a pretty small class, but I wanted to choose numbers that weren't really large and obnoxious. So I started with 8. Okay, so this is really 8, a permutation of 8 to choose 3 items. So 8 factorial, so the 8's on the top. And then the difference of the 2, right? That's 5 factorial. Now we could write this, do this a slightly different way. I could write this as 8 times 7 times 6, but instead of saying 5, 4, 3, 2, 1, could I also just say 5 factorial, which is 5 times 4 times 3 times 2 times 1. And I do that because I have a 5 factorial on the bottom. And now I can cancel out 5, 4, 3, 2, 1 with the 5, 4, 3, 2, 1 up here. So I can cancel out this 5 factorial with the 5 factorial just to save myself a little bit of time. Okay? And so on the bottom we just have a 1. Upstairs we have an 8 times a 7 times a 6. 8 times 7 times 6. 336. So 336 ways he can choose an order of 3 students out of a class of 8. All right, next one. 7 people have applied for a job with your company. The head of the Human Resources Department is going to schedule interviews with 4 of them at 8 a.m., at 9 a.m., at 10 a.m., and then 11 a.m. So the order matters because they're setting up a schedule. In how many ways could she choose and arrange the 4 candidates for the interview? So how many different ways can she pick and order 4 people out of the 7? So write what the numbers go here. I'll give you a second. All right, so that's 7 total that we're starting with. We're choosing 4. So the 7 goes on the left, 4 goes here, and then we have 7 factorial over the difference, 3 factorial. I think I have more lines here. I'm going to just skip to this one. So this is 7 times 6 times 5 times 4 times, and here I'm going to just say 3 factorial because that's what I have on the bottom, 3 factorial. Now you could certainly write 3, 2, 1, 3, 2, 1, and then cancel all those 3 with all those. Or you could just stop and use the factorials. Okay. So this is 7 times 6 times 5 times 4. Let's see, I can do this without my calculator, I think. This product is 42. This product is 20. This looks like, what, 840? Okay. All right, let's try number 4. In how many distinct different ways can the letters in the word dame be rearranged? Now, we're not counting how many ways they can make an actual word, right? The rearrangements may not make an actual word in the English language. All right, write them all out. Okay, so take a second and write out all the different ways I could reorder these. Now, this is sort of something different. There's a different formula for the ordering of letters in a word, and we'll talk about that more. So pause the video and then write out those. See how many you get. Okay, let me write mine out now that you've come back to the video. I'm going to try to be systematic in the way I do it. So let's see, I can do DA, again, DA, and then I can rearrange EM. And then what if I stay with D in front and I go with E? Then I can do AM and I can do DEMA. It's supposed to be an A. Okay. Now let's see. I could also go do DM first. Well, second, and then AE, and I can do DMEA. All right, so that's all the ways D can be first. Now, how many ways can I get, let's say, A to be first? So A, D, E, M, A, D, M, E. I'm going to try to do this a little tighter. I'm afraid I might run out of room. Then I have A, what could be second? A, E, D, M, A, E, M, D. All right, then I could do A with M, A, M, D, E, A, M, E, E, D, D, E. All right, so I've got both of those. So I think that's all the ways that A can be first. All right, now, what about E being first? Yeah, I definitely am going to make this a little tighter so they can all fit. So E, A, D, M, E, A, M, D. All right, now E, M, A, D, E, M, D, A. Let's see, how else? E, what else needs to be second? D, A, M, E, D, M, A. All right, I think that's all the ways that E can be first. And now I think the last letter M. So M, I think you can probably see the pattern. It's going to be 6 different ways that I can write M first. M, A, E, D. M, A, D, E. I'm going to go over into this space. I just didn't realize I was going to have so many when I first started writing. M, let's do E next. A, D, M, E, D, A. All right, and then finally M, and then D. M, D, A, E, M, D, E, A. All right, so that's how many ways. So it looks like 1, 2, 3, 4, 5, 6. Looks like 24 different ways that we could do it. So the only way you can really do this is if you try to be systematic. If you just started writing letters down, you invariably forget or miss one of these, or possibly repeat one and not realize it. So it looks like there's 24. So there's 4 letters in here. So if we did something like, oh, I don't know, 4 factorial, that sounds like that would be 24. Okay, so that seems to work, right? 4 factorial, how many different ways? So this is really just a permutation of 4 items of which I'm choosing 4. So we really could have used the same formula that we used before, and that's 4 factorial over the difference, which is 0 factorial. Well, that's just 24. 4 factorial. Okay, now that's kind of what we've been doing. However, now if you look at example 5, we have repeats. We have the same letter twice. So I could take those 2 and rearrange them, and I wouldn't really have a different arrangement. But if I use the same approach, like if I treat it one as A sub 1 and one as A sub 2, like they're different, then I'm going to have 24. Right? Because this A and this A are now different because I marked them as distinct. But that's not how our letters are. Our letters are the same. So let's do the same thing. For Adam, let's write out how many we have. So we have A, D, A, M. We have A, D, M, A. All right. What else do we have? We have we have A. That's the only ways I can do A and D. Let's do A, D, M. A, M, D. How about A, A, M, A, D, A, M, D, A. Okay, so I think that's all the ways I can do A first. The D's, and then the A's are second, and then the M's are second. So that's the only way I can write with A first. All right, now let's do a D first. D. A, M, D, A, M, A. Now D, let's do M. D, M, A, A. I can't rearrange the A's because that wouldn't give me a different arrangement. Okay, so let's see, what else am I missing? I think that's the only ways I can do D first. I've reached these, and okay, so now let's go to M first. So M, A, D, M, A, D, A, M, D, A. And again, I think that's it, because I can't rearrange the A's any other way. So notice there's quite a few less, even though we still have four letters. This is it's not going to be a permutation of 4 choose 4 because of the repeated letters, right? They're not 4 distinct letters like dame was. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like 12. And so this has got to be a slightly different formula than what we saw on the beginning of this page. It's not going to be the same kind of permutation calculations that we saw on the first page here. So let's look at the formula. So the formula to figure this out is n factorial. N is the number of letters. Okay, and then for each category of letter, or each category of item, in this case, distinct letter, we're going to list how many times it shows up, factorial. So we have n sub 1, n sub 2, n sub 3 for how many different type letters we have. So I have to write this very generally because I don't know how many letters. So let's look at this atom, the word we just did. On the other page, we said there were 12 different ways of writing it, and let's see if this formula works for us. So we have 4 factorial upstairs. All right, then atom. So let's start one letter at a time. A, how many times does A show up? Twice. So 2 factorial on the bottom for the A. D, how many times does D show up? Once. So that's a 1 factorial. And then an A we already took care of, so we're not going to put it down a second time because it's for each distinct letter. And then M, how many times does M show up? 1, so 1 factorial. Now, you pretty quickly realize that 1 factorial isn't going to do anything. 1 factorial is just 1. So we could really just get rid of those and only put the letters factorials down below that are repeated. So we wouldn't bother with the D or the M. I mean, you can put them in, but 1 factorial is just 1, so it's not going to really affect it. So we have 4 times 3 times 2 times 1 over 2 times 1, and then we could, again, just ignore the 1 factorials. So that cancels with that, and sure enough, that gives us 4 times 3, which is 12. Okay, so it seems like that formula works for atom. Let's use that same formula for other letters, other words as well. Okay. So stop the video and try doing it on your own for Mercedes. Okay, so Mercedes, 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial on top. And then we simply do go through them one at a time. So M, only once, so I'm not going to bother writing it. E, so E is 1, 2, 3, so that's a 3 factorial on the bottom. R only shows up once, doesn't repeat, don't have to worry about it. S, looks like S shows up twice, so 2 factorial. E, we already did. D only shows up once. E, we already did. And S, we already did. So it's 8 factorial over 3 factorial, 2 factorial. So when you have multiple factorials, it's probably better, well, let's just write it all out. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. All right, so 3 factorial, 2 factorial. Okay, so I'm going to cancel some of these. Like I can cancel the 3, 2, 1 with the 3, 2, 1. And then I could reduce this more, or at this point I could just pick up a calculator, multiply the tops together. Let's see. So we're going to do 8 times 7 times 6 times 5 times 4. That gives me 6,720. On the bottom, I still have a 2. So divide that by 2. And so this is 3,360 ways to order different orderings of the letters in that word. Okay. All right, let's try. Now I purposely, this looks like the word letter, but I purposely put an extra E in there just so that it was a little more interesting as far as the number of letters. So pause the video, do number 7. All right, 1, 2, 3, 4, 5, 6, 7. We have 7 factorial. And then let's see, L does not repeat. E is 3 factorial. T is 2 factorial. E we already did. R does not repeat. All right, so 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. So you could cancel this in a couple different ways too. I could do the 3, 2, 1 with the 3, 2, 1, but 3 factorial, this is 6. So I could cancel these out with that 6. I could cancel the 2, 1 with the 2, and well, with the 1, right? And then just multiply together what's left. The bottom is all turned into a 1, and then multiply what I didn't cancel. Or you could just multiply everything together and divide by everything that's on the bottom. So, I mean, it doesn't really matter how you want to do it. Okay, 7 times 5 times 4 times 3, 5, 4, 3, 5. No, sorry. 7 times 5 times 4 times 3. I get 420. Okay? All right, try number 8. As far as I know, this is not a word. It almost looks like reminds me of like the train company in Spain or something. I don't know, the national train, but it's not really, I don't know. So I just made this up, I think. Okay, so count the letters. 1, 2, 3, 4, 5, 6, 7. So 7 factorial, I believe. 1, 2, 3, 4, 5, 6, 7, yep. And then R does not repeat. E is a 3 factorial, repeats 3 times. N, no. C, no. T, no. Okay. So we just have 7 factorial over 3 factorial. So that's going to be 7 times 6 times 5 times 4. I'm going to do this times 3 factorial over 3 factorial and just cancel the 3 factorials. So now it's 7 times 6 times 5 times 4, 840. All right, number 9. Mississippi. So pause your video and then try that one. All right, Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's 11. 11 factorial. All right. M does not get repeated. I, 1, 2, 3, 4 I's, so that's 4 factorial. S, also 4 factorial. Done the I's and the S's. P's, the last thing, and there's 2 of those, so 2 factorial. Okay, so 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, and then 4 factorial, 4 times 3 times 2 times 1. I'm going to cancel this one with that. And now this 4 factorial, remember 4 factorial, instead of writing it as 4, 3, 2, 1, I could just say times 24, because that's what 4 factorial is, and then times 2. All right, so in my calculator, I'm just going to do 11 times 10 times 9 times 8 times 7 times 6 times 5, and then I'm going to divide by 24 and also by 2, so I could just divide by 48. So take that total. Well, let's write out that total. Oh, that's a big number. 1,663,200 divided by 48. So divide that by 48. All right, a little bit smaller. 34,650 ways of rewriting the word Mississippi, the letters in the word Mississippi. All right, last one, statistics. Pause this video and then work on it. All right, statistics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial upstairs. All right, let's start with the S. Looks like what? 3? 3 factorial. All right, T. 1, 2, 3 T's, 3 factorial. A, there's only one A. T we've done. I, looks like 2 factorial. Let's see, T we've done. I we've done. C is only repeated, not repeated. And so then S we've already done. Okay, so again, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial. So I can cancel out one of my 3 factorials with 3 factorial. And then remember, 3 factorial is just 6 times 2. So let's go ahead and just multiply all that together in the calculator, and then we'll divide whatever that is by 12, because that's what's on the bottom. Okay, so let's do 10 times 9 times 8 times 7 times 6 times 5 times 4. So I get 604,000. Is that 800? 800. And now I'm going to divide that by 12. All right, so I get 50,400 ways of doing that. Okay? All right, so you should be submitting, I think it's page 1, so the back side of this, submit page 1 on Google Classroom as today's classwork. So submit page 1, and then your sub should give you, oh no, you don't have any homework tonight. No. The homework that's listed on the bottom, tomorrow is supposed to be a short day, I think. So I'm going to leave that worksheet tomorrow for the sub to hand out. So we won't have another video tomorrow. Tomorrow you'll just spend class time working on your homework, which will be due again the next time I see you. All right, because I'm going to be out again tomorrow as well. I think I'll probably be back on Friday. So anyway, this homework, okay, which I assigned last class, and this homework, which will be assigned next class, will both be checked when I see you next. Okay. So again, don't forget to submit page 1, and I'll be looking at that. I have my computer with me, so I'll probably check all that in at some point today when I get a break from our DECA trip. Okay, I'll see you soon.